Anybody? That lady, she's always here. Anybody have any questions from homework stuff or anything in general? Have you guys taken a look at the quiz that you hopefully did? Anything? Any questions from the quiz or from homework? I don't know. I'm going to wait. I'm going to talk about the quiz a little bit later when more people log in. If there's no questions, I'm going to jump right back into chapter 8. We have finished chapter 7. We got a little bit into chapter 8 last time. So remember, next Tuesday is the quiz on the rest of chapter 7, right? That would be the, oh, I got somebody coming in. That would be the difference of squares and the difference of cubes and all that kind of stuff. Let's do this. So we finished up chapter 7, but let's review the last section of 7. Since nobody's asked me any questions, I'll turn off my forest. Turn you off. Bam. Whoa. Let me see here. Get that going there. Get up there. Get up. All right, let's go. Oh, okay. So the last section in 7 dealt with the most basic use of factoring that there is. So if I have an equation like this, okay. If I have this kind of an equation, what do I do? How do I solve this? No tricks, no anything. This is easy, easy, easy. Nothing, no tricks.
Add the 2x.
Yeah,
Both
get your
sides.
x's together. Get all your x terms together. And of course, then I would get my numbers on the other side and then divide, and then everything's great. Right? Okay, so that's the old days. I mean, we already talked about that. Why would I suddenly be giving you problems like that again? It's because you need to know when to use the new stuff we learned. So the new stuff doesn't apply to this. Why would it? I know how to solve this kind of thing. When the x's are to the first power, they are like terms. I can put them together. I can get all my x stuff together into one place. That's why I can do this. So if I have a problem that's like this, let's say I have x squared. What do you got, Jeff? Minus 5x plus 8 equals, what is it, Jeff? Spit it out. I don't know. 17 minus 5x. I love it. So what piece of this is different? What tells me I have to do something different?
X squared?
Yeah, it's got a x that's got a different power, a higher power than 1. Therefore, I must do what now? What's the process we use now that this is not in the form of equations that we know what to do with? We developed a new way to do this. What do I do? What do I try to get happen on this side here?
Make the right side equals 0.
Yeah, try to get this side to be 0. Because I know eventually I'm going to want to factor. And we discussed the fact that if I have something times something equals 0, that's the only time I know something for sure. One of them has to be 0. If it equals anything else, I don't know shit. I don't know anything. So let me move this stuff over. Subtract 17, add 5x. So what happens? Like an x squared
0.
Yes. Those cancel. 8 minus 17.
-9.
Now, don't do this. Some people just make that whole thing disappear like it's not even there anymore, and they factor that and they circle it. This is an equation. You only know you're done when you get the answers. This is the one time you can get number solutions, is if it's in an equation. So how do I factor this side? What form is this, and how many terms are there? There's 2. No
Two.
GCF.
X plus 3 minus 3.
I like it. So this is, so again, if you don't understand factoring, you desperately need to do something about that. You need to let me know. I've met with people with individualized office hours on Zoom. I could do that with you if you want to shoot me some suggestions on times, if you want to get some more time, or get some resources. I mean, because not only is the last section in chapter 7 going to deal with factoring, you've got to be able to factor to do it. The entire next chapter will require you to know how to factor stuff. Let me see. I've only got 9 people here, but all right, I'm not sure where people are. It's a little disappointing. But I do want to say one thing I've noticed on the last quiz especially. I know that some of you guys are using apps to help you get answers. I know you are, okay? Not all of you, but definitely some of you. You need to stop doing that. It's not going to help you. It's not you doing the work. So that is so unfair to the people actually doing the work and getting honest grades. It doesn't mean you know shit if you can copy down what some app tells you to put down. That's complete crap. I understand this is not an easy time. I will be as flexible as I can be, but I will never be so flexible as to allow cheating. Okay.
Professor,
Yes.
I understand this one.
We're not done with this one though.
Yes, can you do another?
No, we're not done with this one though, right?
Okay.
Okay.
Oh, you're not done? Okay.
No, why am I not done? Have I gotten the answers yet? Do I know what X is? No. So what can I say now that I got this factored? What 2 things can I write down? Either
Equals 0.
Yeah, either this is 0 or that is 0. So either I get X is -3 or I get X is 3.
Okay. Like we need the X's. Okay, I got it. It's like the first chapter, like.
Yeah, if you're solving
Yes.
an equation, you're only done once you get the values that work.
Hmm.
Okay, what can happen on this step is anything. Any form of factoring you've ever done can show up here. All right, so let's try another one out.
Okay, 1 second.
I'm gonna erase up here, okay?
Okay.
Let me write down the next one I want to do. I forget what number I was on. Oh, what else do I want to do here? Yeah. Oh, this could be interesting. Let's see.
Yeah.
All right. All right. What's one nice thing I did for you in this problem? What's already true? I was much nicer to you with this problem. Why? What's already there?
0.
Yeah, it's already equal to 0. There's a power that's not 1, but I've already got it equal to 0 for you. Very nice. So all you have to do is factor this. I'll wait. Go ahead and factor this. Real quick, by the way. All right. I didn't say this explicitly because I got the feeling that most people were, it had either been a really long time since you factored or you were learning it right now. But there's a method I will not let you use unless you can tell me why it works. There's a method you can use using this thing that's fine, but some of you guys are doing some shit like, you know, this here, blah, blah, blah. And then you're just throwing numbers in. You don't have a clue why those numbers work. You don't. So that's not acceptable. If you can explain to me why that process works, I will let you do it that way. The really, now some of you guys don't know what I'm talking about with this, and that's great. That's great, because it's a dumbass way to do things, right? So just do it the way I've explained it to you. And I'm not saying that because I'm not open to other ways. I know a few of you guys use this method. And the thing is, the hard part about this problem is done when you get to this method. The hard part of this problem is, what are the two numbers? Right? What's the steps in doing this problem? What do I have to do first?
Make the 3 terms into 4 terms.
True, that's what I want to eventually do, but what do I do to go in that direction? I take
A 3 and 8, multiply them.
All right, and then I want factors of 24 that make 10. What two numbers multiply by 24 and add to be 10?
Say again.
What two numbers?
6 and 4.
Wait. What two numbers multiply to be 24 and add to be 10? That is the fundamental difference when I have a number out front that's not 1. I don't want factors of 8 that add to be 10. I want factors of 3 times 8, 24, that add to be 10. I have to take that 3 into account.
12 times 2.
12 and 2 would work if one of them could be negative.
Negative's gonna be 10.
No,
No?
nothing
It's
could
a
be
positive.
negative.
Yes.
Nothing could be negative then, so that won't work. Yeah,
It's
so
not
it's gotta
working.
be 4 and 6.
Okay. Yes.
Yeah, so 12 and 2 would work if that had been a minus 8.
Yes. Yes.
And it would have been a negative 24, yeah.
You're right.
Now, right here, some of you would do this weird ass thing and you would take, I think you do 4 over 3 and 6 over 8 or what, I don't know.
Not over, just numbers.
But this is completely insane.
Yes.
Completely insane. Because for one thing, you're doing something you don't even know why it works. And some of you guys are looking at me like, I do that all the time for you. But you really don't know why that works. I know you don't. You just do it because somebody showed it to you and it gets the right answer. So it's exciting. But you have no idea why it does. And I don't like that kind of shit. Right? I really want you guys to understand what it is you are doing. So what I can do, since 4 and 6 add to be 10, that's where they came from, I can rewrite this as plus 4x plus 6x plus 8. Let's see, this poor little thing. Here. And now that I've got it as 4 terms, like Yansha said, I can group. So then I get x times 3x plus 4 plus 2 times 3x plus 4. So then I can take a 3x plus 4 out. I'm left with x plus 2. Stop for a minute. On the quiz, some of you guys had these numbers come up out of nowhere. Just out of nowhere. You should know me better than that. I should have worn my show your work shirt today, but I shouldn't have to do that because I've done it. And the minute you see somebody wearing a show your work shirt, work is important to that person. You just know that about this person. I don't care if you get the right answer. I really, really don't. I really want you to understand that. It's about this process, right? It's the process. So if you don't show me the process, how the hell can I grade anything? I've got to assume the worst. Okay, I'll try to stop. I'll try to stop. I was just really upset when I was grading. I could just tell so many people. All right. So what can I do here now? What has to be true? Either.
-4.
No. Come on. Either this is.
Oh, okay. Or.
I can't solve it until I got it set up. Right? Either that one is 0 or that one is 0 because I have this number times that number is 0. So one of them has to be 0. So just to cut to the chase, subtract 4, divide by 3, I get -4/3. And then subtract 2, I get -2. Okay. So if you put either one of those numbers into the original, this would become 0. Okay. Give you guys a minute.
Done.
All right. So that's the last section in chapter 7. It's like a review of all the factoring, except you have one more step. You got to actually find the answers now because they'll be in equations. Now, what unfortunately happens, now watch. If I said this, watch, interesting things happen now. If this is the question, this is not too bad. Or how do you factor this? Two numbers that multiply every 24 add to -11.
-3 and a -8.
But then I get people that put it equals 0 here and they keep going. Where does it say this equals 0? And to me, it's kind of like the most depressing view of the universe. Everything equals 0, Jeff. No, just because we learned what to do when I can make something equal 0 doesn't mean that everything suddenly equals 0. This is not an equation. I'm not going to get values for this. I can just rearrange the, I can do something with this expression. I can't solve it. Okay, maybe. So, coming back to, oh, let's do one more of these. I guess I'm on number 3, maybe. Let's see. We did one like this last time. Let's see. Maybe make it work. That would be nice, right? Do you want it to work? Yeah. So what is fundamentally wrong with this problem?
Equal 15?
Yeah, it's supposed to be equal to 0. So again, this isn't necessarily true, but the way I look at this problem is, somebody factored it before they freaking made this 0. I got to undo what they did. I got to multiply this back out so I can suck the 15 in. I can subtract the 15 over, right? So I have to multiply this back out, 2x squared plus 6x minus x minus 3 cal. And then I can do the minus 15. Oh, yeah. 5x and then minus 3 minus 15. Right? So if it's not 0 over there, this side can't be factored yet. So I have to unfactor it. So multiply back out. So then I can take the 15 over. Go ahead and finish this out. Let's see. Okay. Yeah. Let me
Professor,
catch up to you a little bit. Yes, sir?
we have positive 6 and up. How you got 5x minus x? Okay, I got
Right. So you get 6x and then you get minus x. I'm just putting the two middle terms
it.
together.
Okay, you
Yep.
got it. I got it.
And you get negative 36. Factors of that add to be 5. That was not too bad.
Okay.
Right? What do you guys? Is that cool? 2 times negative 18, negative 36. Factors of negative 36 that add to be 5.
9 and negative 4
Good.
plus together equals 5.
Good. So then I can rewrite the middle term as I'm going to put the negative one first, and then minus 4x plus 9x. So do you guys see how I'm never really sure how you guys feel about this. I went over a few times why this process works, what the motivation was for trying to do this, right? But on one level, just realize I haven't changed this. Negative 4x plus 9x is 5x. So I really did nothing. I didn't change anything, but I did rearrange things so it falls into a form that I really enjoy because it's one of the easier forms of factoring. That's grouping now, right? I can group it. And then something else people do is they will forget to bring the equal 0. So they'll think they're done here, but it equals 0. So you're not done. You have to actually get the answers. Right, so x minus 2 is 0, or 2x plus 9 is 0. So x is 2, or x is negative 9 halves, if you solve that. Uh-oh. Now, is this a longer problem than we're sort of used to? Yeah. I don't care. As long as the steps make sense. This is what I call math stamina. I can't remember if I've used that phrase with you guys before. But people do this and then they sort of like, screw it. And they go to the next problem. Why not finish it out? I know it's a little bit longer than we're used to, but.
We have to plug those back in when we're doing our homework and on a quiz.
No. I mean,
Okay.
if they ask you to check your work, which I don't think they do, you could plug them back in to check, but you don't have to.
Got it. Thank you.
And just to show you, I think I told you this before, when I made this problem, how did I know it was going to work? Because I used the value of 2. 2 times 2 is 4 minus 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. That's what told me what number to put here. So I knew 2 was going to be an answer, but I didn't know what the other answer was going to be. No idea if that made sense, but that's how I make a problem. If I would have put some other number there, more than likely it would never work this way. It wouldn't be a nice answer. And I know you guys think that this is an ugly answer. This is a beautiful answer. It could have been 5 minus the square root of 17. Is it? This suddenly looks a lot better now, right? I mean, yeah, okay. All right, how are we doing out there? Anybody still copying that thing? No. Nope. Okay. All right. So let's get back into where we left off. We started getting into chapter 8 just a little bit. Let me ask you this. What value can X not be? And this is such a weird question. If you know the answer, hold on. Don't say anything. Let's do this instead. Let me see. Let's do this instead. Let me bring back some of your favorite notation here. Remember this? All right, maybe not. What is f of 7?
1.
Yeah, because you get 2 over 7 minus 5, 2 over 2. That is 1. Is everybody with me? What is f of 8? 2 over 8 minus 5, 2/3. Is that all right? I mean, that's just plugging stuff in for x. Nothing amazing. So my point now is, for any value of x, that is most likely a fraction. It might be reducible sometimes, but for most values of x, that is going to be a fraction. What cannot happen in a fraction? There's a certain value you can't have somewhere in a fraction.
0?
Yeah, you can't have 0. Where?
On the bottom.
On the bottom. So what value of x would make that happen?
X minus 5 cannot equal 0.
Okay, good. I love it. I actually enjoy that answer. You didn't answer me. You actually told me how to get the answer. I love it. X minus 5 can't be 0. Is that what we're saying? The bottom can't be 0. If I solve this, I get that x can't be 5. Because what happens if f is wait a minute. If x is 5, if I plug a 5 in, what happens to this thing? I get 2 over 5 minus 5. 2 over 0. What's 2 over 0?
Undefined.
Undefined. No good. So when the problem asks, what values can x not take on, or whatever the hell they're going to say, then you just have to figure out, when is the bottom 0? I can't use those values because I can't divide by 0. So with that in mind, okay, nobody's yelling at me. What values of x are not allowed for this problem here? What you got, Jeff? Sure. Jeff's on. Yo.
So first factor the bottom.
Yeah. Okay, good. All right, stop. Right? So some people get really confused. They know it has something to do with 0. So some people just tell me x can't be 0. But of course x could be 0, right? You guys see how x could be 0? 0 plus 0 minus 18. Yeah, any value that makes the bottom 0. So what you do is you do this. You say the bottom, in fact, let's say it in English. Here we go. In English, bottom can't be 0. Now, you're going to have to take my word for it. That is English. That is really horrible. Oh, my God, Jeff. Bottom can't be 0. All right, that's closer to English. So the bottom, what's the bottom? X squared plus 3x minus 18. Can't be 0. And how do I solve this? Like Youngsha said, you factor this thing, right? How do I factor this?
X.
So Melissa, real quick, Melissa's got a really good question. Not quite. I mean, it is infinite in one sense,
Six
but
and
that's
three.
not an answer, is it?
No.
Infinity is not a thing, right? Infinity is a process. So that's a very unsatisfactory answer once you know what infinity really is. So if I ask you, what is this thing? And you say, it's an infinite number of things. I'm like, what? What? So that's why we like to call it undefined, because it's not only why we like to call it that, it is what it is. And that goes along with infinity being not a specific thing. So it's undefined. So it's bad, right? And in later mathematics, you can divide by 0 and get something that isn't infinite. So that's why I don't necessarily like to say, I know teachers sometimes call it infinite. It isn't quite that. Okay, I don't know if that's a good answer for you, I'm sorry, but okay. But even if I did say it was infinity, it's still not allowed. It's not really a thing, so it's not really an answer. So what works here? What do you got?
6 and 3.
And of course, 6 is
Minus.
no.
Positive and minus. Why
Why is
yesterday
it
you
positive?
said
Because the bigger one's got to be positive. So then I get x can't be -6 and x can't be 3.
Okay.
If you plug a 3 in, you'll get 4 over 0. If you plug a -6 in, you'll get 4 over 0, and that is not allowed. I like it. So you're going to have some questions that just say, what values of x are not allowed, right? There's no solving it except for the fact that you set up this. This is what condition has to happen for it to work, is this can't be 0. So you can tease out exactly what values do I have to throw out. So what about this one here? Make sure you guys are really looking at the right thing. What values of blah, 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 blah. Same instructions. Let's see. Let's do this. Let's see who's really, really, really paying attention. Same question. What values of x can I not use? Excellent. Anybody? I'm letting you answer now. Anybody have the answer?
divide, like we divide?
All right, I'm sorry. It's the same question I was just asking. What values of x are not allowed? So I'm not asking you to simplify it. I'm just asking you this same question we were just doing, right? Good, Melissa. So I'm not trying to trick you. It's exactly what I said. The bottom cannot be 0, right? So again, in English, bottom can't be 0. That's mathlish, right? The bottom is x plus 6. So x can't be -6. The top can be whatever the hell it wants to be. The top can be 0 all day long, because 0 divided by something is 0. It's not something freaky like infinite, right? So it's just the bottom that I have to worry about when the question is what values of X are not allowed, or some version of that. Okay. All right. Moving on past that idea. Now let's get into simplifying. I'm going to use this ported up. Let me switch over. Come on, work. Come on, work. Let's see who remembers what we talked about last time. Please notice we've changed instructions here now, right? Just simplify, not anything about what values make it work and all that kind of stuff. What the thing you cannot do, which is kind of evil on this problem, to be honest, because it sort of looks like it works, but you can't divide 16 by 4. It's no, because division cannot cancel parts of subtraction. So who remembers what you have to do? I don't have to do long division, thank God. Because what works? What could I do to the top? What can I do to the top?
Divide.
Do it, sorry?
Divide.
No.
Simplifies. Okay.
I can factor the top. Right? How do I factor the top? Blush, I think. How do I factor this? X squared. Right? How do I factor? So I'm leaving the bottom alone. I don't know if you guys are freaking out. The bottom is still there. I'm just looking at the top. How do I factor the top?
8 and 4.
No. Why 8?
8 and 4. So 4. 4 multiply 8, 16.
4 times 8 is?
4 times 8, 16. Oh, no.
No.
Yes. 4 times 8.
4 times
Yes,
8 is 32.
Sorry.
Yeah. It says squares, right? It says squares. What times itself is 16?
4.
2 and 4 and 4.
And now I can see what cancels. Why does it suddenly able? I couldn't cancel anything here because division does not cancel subtraction. But what operation is here? Multiplication. So division goes, oh shit, it's my turn, right? It's like Hawkeye down there. Do I get to do something?
X minus 4. Yes.
Yeah, the X minus 4s cancel. So your answer is X plus 4.
Plus 4.
Because the X minus 4s canceled.
Okay, I got it.
Let's just do something that's more interesting. What about this one? Let's see. Yeah, that one's, ooh, I love that one. That one's nice and gross. Is that gonna work, Jeff? Yes. Ha ha ha, that's, oh man, that's so yummy. So what you do, you factor the top, you factor the bottom, and then you see who wants to die, and you let them die.
Oh my gosh.
Okay. So again, chapter 7, you would get that problem, and then you would get that problem. Chapter 8, 2 problems in one. So just look at the top, factor it, look at the bottom, factor it. Don't worry about the new stuff until you got everything factored. The new stuff is just kill whatever is the same. They cancel. This is what I mean by if you don't know how to factor, you shouldn't even try chapter 8. Oh my God, you're not going to be able to do anything.
-9 and 2.
Yeah, so
For the top?
-9 and +2, I love it. And then the bottom, of course, what form is the bottom in?
Cube.
Yeah. So it'll be little dude will be 1x and 1, 2. Big dude will be 2x's minus 2x plus the other 2 2's. So can you see anything? Let me see. Wait, for the previous problem, after remove the x minus 2, we still have to note that 4 can't be an answer. Oh, it doesn't really ask you that question, Melissa, but in general, yes. Even if I have this, because it came from this, x can't be 4. Because what's the one time I can't do this is if x was 4. Okay. So you're right. You're good. That's a good point, Melissa, but that's nothing we're going to have to worry about in this class. Okay. So what cancels out here?
X plus 2.
What cancels out right there? Yeah, x plus 2 cancels.
Can you move the screen over?
Is that better?
Yes.
So then what's left will be x minus 9. I don't know if it's, yeah. X minus 9 over x squared minus 2x plus 4. Those are the survivors. They survived. These guys kill each other. And real quick, this is very interesting. Do you see how the top here is the second power and the bottom is the third power? And I reduced it, and now the top is a first power and the bottom is the second power. I don't know if that's interesting to anybody. It might be just me.
I get it now.
So it really, really, really is, if you get factoring well enough, this is easy because it's just 2 factoring problems with that one extra step of kill anybody that's the same. There's no life lesson there, by the way, kids. All right, only do that in math. You're the same as me, you must die. No. So these are the same. So division of something by itself is 1. So effectively it cancels out. Okay. Let's try a couple more out, and then I'll give you the rest of the day off. So what about this one here? Wait a minute, 3. What you got, Jeff? Yeah. Yeah, I like it. I'll give you a little bit of a hint. Now, this problem, it didn't happen, but I want to do this problem right now to show you. Can you guys really quickly see that there's no way in hell to factor the top? No, Veronica, we can't.
Yeah, we can't factor on the top.
Yeah, you can see really quickly there's no factors of 9 that add to B3. There's no way to do that. But the thing I want you to remember is a part of a cubes will always be a big dude, right? The big dude. And maybe the big dude that comes from him is actually what this is. And some of you guys might be able to say, see, yeah. So if you factor the bottom, go ahead and try to do that problem. Try to factor the bottom. I know that cubes is the most hated form of factoring. Some people are like, I don't discriminate. I hate all of it, Jeff. I'm like, all right, fine. But normally they're the most hated ones. Poor little things. We created them and then we hate them. It's just so evil. So I'm going to focus all my attention on the bottom. I'm going to rewrite the top because it's not factorable. The bottom, little dude, big dude. Right? XXX. 27 is
3, 3, 3.
I like it. So I'm going to put one of each. And the little dude, same sign. What goes in the big dude?
X squared.
X squared. The middle term is going to be positive or negative?
Negative.
Active.
Yeah, opposite sign. I like it.
And then 9. Oh, I'm sorry, 3x.
And then plus the other two
9.
threes, 9. And sure enough, yeah, that and that are the same, right? So you have this divided by this times, so I can kill those. So then what will the answer be?
1 over x
Yes.
3.
So the answer is not x plus 3. That is not the answer, because where is that x plus 3?
On the bottom.
And what is something divided by itself?
1.
Yes. All right. All right. Okay, I think we could stop there. What do you guys think? Because the next section is basically that. In fact, let me just immediately make you hate me even more. Let me do one quick little thing. Yeah, you think you're funny, math boy. All right. Do you remember, how would we do this problem? Real quick, real quick. Nothing major, nothing major. Remember doing this kind of problem? What did I highly suggest you do first instead of just multiplying?
Reduce.
Yes.
I don't know the
Was
proper
it
term, but
18 is 9 times 2, right? 25 is 5 times 5. So then the 9s cancel. Now, of course, would we do this shit? No, because I know 9 goes into 18 twice, but you can see it now. I know that 5 goes into 25 5 times, but you can see it now. So then what's the survivors? 2 over 5. So the next section is really this. It's just going to have another thing over here. Blah, 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 blah. Right? And you factor, and then kill anything that's on the top and the bottom, because they would be opposite operations. Okay. Coolness. I think, I don't know if it was this class, somebody just asked me a question privately about something. If I think there was some, I can't remember if it was this person or not, but if you have trouble with the quiz or if you miss it, it's exactly like in the classroom. I don't take late quizzes, right? Somebody tried to turn the quiz into me at the end of class after I'd already collected them. I'm like, ain't no way I'm taking that. What I can do, if you remind me, and I still have to do this for, I think Hayam, I still have to do this for you, is I can make a makeup quiz, because now the quizzes are the tests and the tests are the quizzes, right? So it's, I have to give you a chance to make it up, but I'm not going to let you do the same quiz because now people have gotten results back. Okay.
So it's okay if different quiz because I don't. It's okay if different quiz because I have to do it, you know.
No, I know. Of course it's okay because that's what I said. Haha. But I know what you mean. I just have to do it. Someday I'll do it. All right. So just keep on me about that if you need to do a makeup quiz.
Professor, I
Yes.
have a homework question.
Okay.
Chapter 76, page 875. 875, 339.
Number 339.
Yeah,
Which section?
76.
76.
Yeah.
339. Let's see.
16.
I got you.
Yeah.
Okay. Oh yeah, you're the one. Somebody just messaged me. So just stay on me about, just email me, remind me about the makeup quiz. Anybody who needs to make up the quiz, just, and if I don't get it made right away, just go, I'm just happy he's letting me take a makeup quiz and not getting a 0. Just always keep that in your mind. Okay. So this one says 339, 16p cubed, 24p squared plus 9p, right? This is kind of cool because what's the highest power here?
3.
Yeah, so I expect 3 answers. So what do I have to do?
Make the right side equals be 0.
Good, so I'm going to subtract that stuff over. And then what do you always try first, of course?
GCF,
Mhm.
take P out.
That's right.
And then I tried, yeah, the big part.
Yeah.
It seems cannot factor.
All right, so that's possible because I noticed that if that was a plus, this would work. So I think it might be a typo in the book. But yeah, I think I agree with you. This probably can't factor. Let me see. Just looking at it, it kind of feels like I don't see how it could possibly factor. In which case, you only get this answer. What answer do you get?
P equals 0.
Yep. I think there's a typo. They probably meant that to be a plus. Because if that was a plus, you could see that it would work. But the way they've got it written, I think I agree with you. I'd have to try it, but I'm almost certain that it cannot factor. I don't see how it could.
Yes.
Yeah, I don't see how it could. Yeah.
Then I have no question. Thank you.
Good. Okay. Like it. So that one's a freaky one, guys. That's number 339 in 7-6.
Yeah.
Anybody else? Any questions? How crazy is my hair? Yeah. I'm going on no haircut for a long time.
Okay, thank you. See you next week. Bye-bye.
See you. Bye. Bye. All right. Bye, everybody.